Good morning, students. Today we are going to discuss about the structured question of chapter Structure of Atom and Particles of Matter. So, first question is the diagram shows the nuclei of five different atoms. I am drawing the diagram. First atom having two neutrons and one proton. This bold one is shown as proton. Two neutrons and one proton. This is for neutron and the bold one is for protons. Second nuclei, one proton and one neutron and two protons. Third one, three neutrons and three protons. Fourth one, one, two, three, four, five, six. Six protons, bold one, and five neutrons. One, two, three, four, five. And the last one with six protons and seven neutrons. 1, 2, 3, 4, 5, 6, and 7. So here you can see five nuclei. You have to answer these questions according to these structures. Which atom has an atomic number 3? Atomic number means the number of protons. Yes, the number of protons, we can say it's A, B, C, D, and E atom. Okay, which atom has an atomic number 3? You can see here 3 protons. So the number of protons represent the atomic number. So atom C having atomic number 3. Next is which atom has a mass number of 6? Mass number means the number of protons plus the number of neutrons. So in these 5 atoms, which one having atomic mass 6? A mass number 6. So that is atom number C. 3 protons and 3 neutrons, total is 6. So mass number is 6. Second question is, which two atoms are isotopes of the same element? Which two atoms are isotopes of the same element? Isotopes basically having same atomic number but different atomic masses. So here you can see in D and E, the number of protons are same. 1, 2, 3, 4, 5, 6 protons. 1, 2, 3, 4, 5, 6. 6 protons. So both having 6 protons, but the difference of number of neutrons. So D and E are considered as the isotopes of each other. D part is complete the table below to show the number of subatomic particles in both an atom and an ion of potassium. So this is an atom of potassium and here is the ion of potassium. So the number of protons in this atom are, as we know, atomic number is written at the bottom. So here 19 is written. So this 19 is representing as atomic number, which means the number of protons. So in potassium atom there are 19 protons. And for neutral atom, we know that the number of protons and the number of electrons are same. So 19 electrons. How we can calculate the number of neutrons? As we know, A minus Z will tell you the number of neutrons. So A is the atomic mass, that is 39, and Z is the atomic number, that is 19. So when you are going to minus 39 minus 19, you will get the number of neutron, which will be equals to 20. So number of neutrons are 20. In this ion, the number of protons are 19. Here you can see this atomic number, that is 19. But this ion having positive charge. Positive charge mean there is loss of one electron. So as we know, in a neutral atom, the number of proton and neutrons are same. But when there is a loss of one electron, so you have to write electron with the loss of one electron. So you are not going to write 19. You have to show that there is a loss of one electron. So you have to write it 18. And number of neutrons, 39 minus 19, it will be equals to 20. Because there is no change in number of neutrons and number of proton when there is a formation of ions. Next question. Question number 2. The diagram shows the atomic structure of an atom of element X. I am going to draw the diagram here. You can see. One. These bolts are neutron. 1, 2, 3, 4, 5, 6. 6 neutrons and 5 protons. 1, 2, 3, 4 and 5. 5 protons. 6 neutrons, 5 protons. And the first shell contains 2 electrons and the second shell contains 3 electrons. 1, 2 and 3. According to this structure, you have to answer these questions. First question is, in first question, basically you need this diagram. Complete the table. Subatomic particles, electron, proton and neutron, as we know that. What is the relative charge of these subatomic particles? As we know, electron having -1 charge. So you just have to write -1. Proton having which charge? +1. Yes, proton having +1 charge and neutron having no charge. It's neutral. You have to write relative masses. Just you have to write generally the relative mass of electron is negligible. Relative mass of proton is 1 and relative mass of neutron is 1. Negligible because it is 1 divided by 1840 times. It's very, very, very less. That's why we are saying it's negligible. Write the symbol for an atom of element X. This is the element X, so you have to write its symbol. So as we know, this X element having atomic number 5 because of 5 protons. Because of 5 protons, 1 2 3 4 5. Because of these 5 protons, its atomic number is 5. And atomic mass is the sum of protons and neutrons. So 6 plus 5 will be equals to 11. As we know, atomic number 5 and atomic mass 11 is for boron atom. So we have to write here boron, atomic number 5, atomic mass 11. Next question is, draw a structure to show the draw a diagram to show the atomic structure of another isotope of element X. So you have to draw structure of atom that you are going to represent the isotope of this boron. So as we know, isotope having same atomic number but the difference of atomic mass, basically atomic number is the number of protons, so you have to write same number of proton in the atomic structure of isotope, but just you have to change the number of protons. So here you can see okay, here I'm drawing the structure of isotope for this element. This is X elements and we have to draw isotope for this element. So this is the nucleus. It will contain same number of protons, 5. 1, 2, 3, 4, 5. Same as the element X having. But just we have to change the number of neutrons. When we are going to change the number of neutrons, then the total mass number will change. So here you can see 1, 2, 3, 4, 5, 6. 6 number of neutrons. You have to add 1 neutron, then atomic mass will be changed. So you have to draw 7 number of neutrons. 1, 2, 3, 4, 5, 6 and 7. Then you have to draw the number of electrons. Number of electrons will be same because there is no change in number of protons. So first shell contains 2 electrons. Second shell will contain 3 electrons. 1, 2, 3. So this is the isotopic structure of element X, and element X we know that is the boron atom. Next question, question number 3. Here you can see the question number 3. Choose from the following particles to answer the questions below. Each particles can be used once, more than once, or not at all. So first A part is, which atom has only 8 electrons? So from these you have to answer that which one having 8 electrons. As we know, oxygen is the atom having atomic number 8. And as I told you, the atomic number is showing the number of protons, and neutral atom having same number of protons and this as the number of same number of protons and electrons in a neutral atom. So this oxygen atom having 8 electrons. So you have to write here oxygen. Next is B. Has only 4 electrons in its outer shell. So which one having 8 electrons in its outer shell? Yes, the carbon atom having 8 electrons in its outer shell. We know that carbon having atomic number 6. So first K shell having 2 electrons, L having 4 electrons. So carbon having 4 electrons in its outer shell. Next is has only 8 neutrons. So which one of the following having 8 neutrons? You can write here oxygen, or O minus 2. In both cases, the number of neutrons are 8. Both having same number of neutrons, but there is a change of number of electrons in both. Oxygen atom or oxygen ion, in both of them having same number of neutrons. So you can write any one. Okay, D has only 10 protons. So which one of the following having 10 protons? Yes, neon having, answer for D is neon. Neon atom having 10 protons, because we know that neon having atomic number 10 and atomic mass 20. So this atomic number 10 shows the total number of protons. So neon having 10 protons. Last one is has 4 occupied electron shells. So from these, which one having 4 occupied electron shells? So you have to configure each one, then you will come to know that calcium having atomic mass 20, atomic number 20, atomic mass 40, having 4 shell. See how you can calculate this. First shell is K having 2 electrons. Second is L having 8 electrons. M having 8 electrons. The total are 18, left are 2. So 2 in N shell. So total number of shells are 1, 2, 3, 4. So its answer is calcium. Calcium having 4 occupied shells. Next we are going towards question number 4. A student set up the apparatus shown below. I am drawing here the apparatus. Okay, here you can see this is a glass tube which is closed. Here cotton wool soaked in concentrated HCl is placed. Cotton wool soaked in concentrated HCl. Okay, and here I am placing the cotton wool soaked in concentrated aqueous ammonia. Okay, here the 2 points observe X and Y. We are going to answer questions related to this apparatus. Let's see. After a few seconds, while we are setting this apparatus, after a few seconds, white fumes were seen at point X. At point X. This is the point X. So after a few seconds, white fumes were seen at point X in the tube. In this tube, after some time, white fumes are observed. Name the compound formed at point X. So as we know, ammonia and HCl are reacting. Ammonia plus HCl are reacting. It will produce ammonium chloride. One H is attached with this NH3 and chloride ion. This is a negative one, this is positive one, partial positive and a partial negative. So these ions will attach with this ammonia. So you will get the ammonium chloride. So answer is ammonium chloride. Next question is, use the kinetic particle theory to explain this observation. So, according to kinetic particle theory, hydrogen chloride, as we know, hydrogen chloride having atomic mass 36, you can write it in a bracket, atomic mass, that is 36.5. This is the relative atomic mass of hydrogen chloride. So hydrogen chloride having relative atomic mass 36.5, being heavy, diffuses faster, diffuses slower than ammonia, because the relative atomic mass of hydrogen chloride is higher than the ammonia. Ammonia having relative atomic mass 17. That is why they meet at X and produce fumes of ammonium chloride. So this will be the answer for part B. Hydrogen chloride 36.5, relative atomic mass being heavy, diffuses slower than ammonia. Ammonia having less relative atomic mass than hydrogen chloride. That is why they meet at X and produces fumes of ammonium chloride. So HCl having relative atomic mass that is very low, so it will meet at X. Next question. According to kinetic particles theory. Next question is, the student repeated the experiment using a solution of methylamine. This is the formula of methylamine. This one. This one is the formula of methylamine in place of ammonia. So now you are going to now you have to replace in that tube ammonia with, in that tube you have to replace ammonia with CH3 NH2 methylamine. Instead of ammonia you are going to use methylamine. And when you are going to use methylamine, you will get the fumes, the ring at point Y. You have to answer according to this. So the white fumes were seen at point Y. This is a point Y in the test tube rather than at point X. Explain this difference. Why this time you are going to you are getting fumes at a point Y instead of a point X? Answer for this question is methylamine, which having relative molecular mass that is 31, has a similar relative molecular mass to hydrochloric acid. Hydrochloric acid having relative atomic mass 36.5. So that is approximately or very close to methylamines relative molecular mass. Therefore, they diffuse at similar rates and fumes are produced at Y instead of X. So when you are replacing ammonia with methylamine, you will get the fumes approximately at the center of this tube, because the relative molecular mass of methylamine is approximately close or relatively close to the relative molecular mass of hydrochloric acid, that is 36.5, and relative molecular mass of methylamine is 31. So that's why they are diffusing with the similar rate. That's why you are getting the fumes at the center instead of at any corner or near to any one compound. Next, we have question number 5. The question number 5 is, bromine is a halogen. As we all know that bromine is related to the group number 7 of periodic table, and all the elements of group number 7A are halogens. Bromine having two naturally occurring isotopes. Define the term isotope. So you have to define the term isotope. So what is isotope? Isotope, as we know, atoms of the same element having same atomic number, or you can say the same number of protons and different number of neutrons. Atoms of the same element having same number of protons and different number of neutrons are called isotopes. So you have to just define this in part A. Part B is, one isotope of bromine has the symbol Br35. 35 is atomic number and 81 is atomic mass. 81 is atomic mass. So state the number of protons, neutrons and electron in this isotope of bromine. So you have to state the electron, protons and neutrons. So as you know, atomic number is the number of protons. So you have to write here 35. How you are going to calculate the number of neutrons? You have to minus that 35 from 81. So 81 minus 35, it will be equals to 46. So bromine having number of neutrons 46. Last one is electrons. As we know, neutral atom having same number of electrons and proton. So 35 electrons. Part C is, bromine is a liquid at room temperature. Draw a diagram to show the arrangement of molecules in a liquid bromine. Show a bromine molecule. So as we know, while we are going to arrange the liquid molecule, so you have to just draw the random placement of molecule like this. Liquid molecules are randomly arranged. They having very weak intermolecular forces. Yeah, but they having intermolecular forces more stronger than the gases. The molecules of gases are very far away from each other, because they do not have a strong intermolecular forces. Liquid having intermolecular forces higher than the gases and weaker than the solids. So you have to just draw the structure like this, in which you are showing liquid molecules of bromine. Next question. Next part of this question is, a small amount of liquid bromine was placed in the bottom of a sealed flask. After 30 minutes, the brown color of the bromine had spread throughout the flask. So if I'm going to draw here the structure of flask, in a flask you that is sealed, you have placed bromine, liquid bromine. After some time you will observe that all the particles, all the flask having brown color. So which means the particles of bromine are diffused. Use the kinetic particle theory to explain this observation. So you have to explain this observation according to the kinetic particle theory. So you can answer this as molecules of bromine with higher energy will escape from liquid and mix with air molecules. This flask contains the air. So you are placing liquid molecules at the liquid bromine at the bottom and the other part of the flask containing air. So molecules of bromine with higher energy will escape from liquid and mix with air molecules. Their random movement will help bromine molecules to diffuse into air. After 30 minutes, bromine will diffuse completely, giving uniform brown color in the flask. So this will be the answer for this question. You are going to explain this according to the kinetic molecular theory. Molecules of bromine with higher energy will escape from liquid and mix with the air molecules. Their random movement will help bromine molecule to diffuse into air. After 30 minutes, bromine will diffuse completely, giving uniform brown color in the flask. So because of the high energy of the molecules of the bromine, they will try to escape and mix up with the air. After some time, you will observe that their random motion will help the bromine molecule to diffuse in the air and whole flask will contain brown color. Next part of question number 5 is bromine reacts with fluorine to form bromine fluoride. Write an equation for this reaction. So reaction is bromine is reacting with the fluorine and giving you bromine fluoride. So how you are going to write the equation for this reaction? Here I am writing bromine. As we know, bromine having symbol Br. So bromine atom do not exist. You have to write here bromine molecule Br2 plus fluorine molecule F2. They will react together and will give you bromine fluoride. This will be the equation for this question. So here you can write this equation. Next part B of this question, that is another compound of bromine and fluorine is bromine fluoride. Here you can see BrF5. At the above BrF, now you can see the number of atoms are changed, BrF5. calculate the percentage of bromine by mass in bromine fluoride. In this compound, you have to calculate the percentage of bromine. So you know that how to calculate the percentage of bromine. So if you want to calculate the percentage of bromine, you have to write the atomic mass of bromine at the top, at above, and atomic mass of whole compound at the bottom. So denominator will be the atomic mass of the compound and numerator will be the atomic mass of the bromine, because you have to calculate the percentage of bromine. If there is another compound and you have to calculate the percentage of any other element atom, so you have to change this formula according to that. So at the top you have to write the molecular mass of bromine, and at denominator you have to write the molecular mass of BrF5 and multiply it with the 100, because you are going to calculate the percentage of bromine in this compound. So what will be the molecular mass of this compound? So bromine having atomic mass, that is 80, plus atomic mass of fluorine is 19 and number of atoms are 5. So you have to multiply it with the 5. So 80 plus 19 multiplied by 5, it will be equals to 95. Add these two values, it will be equals to 175. So relative molecular mass of this BrF5 is 175. And what will be the atomic mass of bromine? It is 80, as you see in this calculation. So 80 at the top, 175 at the lower, at in the division, multiply it with the 100. Answer will be 45.7%. So percentage of bromine in bromine fluoride, bromine 5 fluoride. 5 fluoride means the 5 fluorine atoms. So percentage of bromine is 45.7% in this compound, in this bromine 5 fluoride. You have to answer these all question in you have to answer all these questions in your copy, in your notebook, and send me the pictures in Google Classroom. And you also have to complete your diary.